Moodle day that day. So, because
Okay.
MPC has class. I'm supposed to give class that day, but since all the schools, you guys are going to be closed, I'm opting to do a Moodle day so that you don't have to come in that day.
All right then.
Okay?
Thank you.
So, and I'm going to set up the quiz so that you can take it from home.
Okay.
Or from McDonald's or wherever you go through your internet during the weekend. Okay? That would be kind of cool to have a bank of students in the McDonald's taking quizzes and stuff. Anyway. All right, well, whatever. Let's get going. All right, so here, so 6.5, this lesson is on inverse trigonometric functions. So we're going to talk about the definition and how to evaluate these functions, applications, and then how to evaluate them on the calculator. Okay. Actually, I'll add that on the calculator. Okay. So we're going to do it without the calculator, and then we'll show you how to do it with the calculator. Okay, so first of all, let's start with the sine function, okay? So the sine function, here's this little gray curve, goes up and down. It passes the vertical line test, so it's a function, but the sine function in and of itself does not pass the horizontal line test. So its inverse would not be a function, except, I don't know if you remember this, but we actually cheat sometimes. When we want the inverse to be a function, what we do is we restrict the domain of the original function. So if I just use this darkened part of the sine function, now this black part here does pass the horizontal line test. So just this part would have an inverse. So the idea is of an inverse sine function, for example, is instead of me giving you the angle and you tell me what the sine is, the ratio of opposite over hypotenuse or the y over r, in the inverse trig functions, I give you the sine and then you give me the angle. Okay? So the inverse trig functions give you the angle. All right? So for example, if I know that the sine of pi halves is 1, then the inverse sine of 1 is pi half. So we're restricting the domain to just go from negative pi halves to pi halves. So the inverse sine is only good in quadrants 1 and 4. Because otherwise it would not be a function. Okay? So the inverse sine. So the angle you give me is from negative pi halves to pi halves. From negative 90 to 90. Okay? All right. So here's the beginning of the notes here. All right, so there's two ways that you can write the inverse sine. You can write it as arc sine x or sine and then the little -1, which we say the inverse sine. So either way is perfectly fine, okay? And they give you the angle. Now, the reason why it's called the arc sine is because back in the day, the way that we used to teach trig was not so much with like where you first learned it with SOHCAHTOA and right triangles. We learned everything, all the trig based on circles and central angles and arc lengths. We don't use that much anymore, but the arc length, see this central angle of the circle is the same as the arc angle. And so because of that, we call it the arc sine or the angle, the arc that has a sine. Usually calculators don't use this notation as much as the sine -1, the inverse sine, but it's there enough that you need to know what it is. Okay. Now, the one thing that it is not is it's not an exponent. So you see right here is that the sine -1y is not 1 over the sine of y. It's not, you don't use the elevator rule on it. It's not an exponent. Okay? It's the inverse notation. So now if I was writing my book, I'd come up with a new notation for inverse, because that is a little confusing. Okay? But it's not an exponent.
Mr. Strong, I have a question.
Yes. When's my book coming out? Oh, no, go ahead.
That too. But what if sine to the -1x is different than 1 over
it's
sine?
not sine to the -1.
I mean,
it's
no.
Inverse sine.
Inverse of sine.
Okay.
Like, what's the difference? The inverse of sine, how's that different from 1 over sine x?
Okay, because it's giving you the angle. It's not a fraction.
Oh.
See, like if I say the sine of 45 degrees is radical 2 over 2, then the inverse sine of radical 2 over 2 is 45 degrees. See, it tells you the angle.
Okay, got it. That makes more
sense. So let's say that that you're an architect and you're wanting to build a staircase, and you want, or maybe let's say a ramp, and you want to calculate, you want your ramp to go, to have this length and this length. Well, by using an inverse sine, you can figure out what the angle should be that you make the ramp. Or anytime you're building anything and you want to have an angle, you use inverse trig. Okay, so anyway, we'll do more applications, but the difference is the inverse trig functions give you the angle. Okay. All right. Okay, so we talked about that. Okay, so the domain of the arc sine is from -1 to 1. And the range of the arc sine is from -90 to 90 degrees, or -π² to π² radians, or quadrant 1, quadrant 4. You can write any of those or all of those three. Okay, the domain of the arc sine is also -1 to 1. The range of the arc sine, or cosine, arc cosine, is 0 to 180, or 0 to pi, or quadrant 1 and 2. So that's different. The domain of the arctangent of x is, and that's the bold R that represents all real numbers. The range of the arctangent is -π² to π², -90 to 90, quadrant 1 and 4. The same as the inverse sine. All right. Anybody need more time on this? Okay, so when we're graphing the arc functions, as I say, the inverse functions, basically you're just switching the x and the y's. Okay? And so, like instead of having the little piece that we cut from the arc sign, so you invert it through the line y equals x, and so your graph is that little piece, only it's going up. Now, really, you don't have to, we're not going to really do much with the graphs, except the one that I would like you to be familiar with is the arc tangent. Okay? So let me just see if you can put that in your calculator. So see if you can graph y equals the inverse tangent of x. See if you can figure out how to put it in your calculator. All right. So your graph should look something like this. Okay? Now, if you didn't get it, let's troubleshoot a little bit. First of all, for all your trig functions, when you graph them, what mode do you need to be in? Radian mode. So if your graph does not look like that, then first check to see if it's in radian mode. All right? Then the next thing you want to do is make sure you didn't just like type in tangent, but that you actually have inverse tangent. Okay? So let's see, let's clear all this out. Okay, make sure I'm in the right mode. Okay. All right, so then I do the y equals, and then to do inverse tangent, that's above the tangent in blue, so you do second inverse tangent of x, and then graph. And then I'm only seeing part of it because of how my window is set. So let's do zoom trig, zoom 7, and then you've got your graph. Okay? Any questions? Now, when you write it on your paper, though, what I want is it actually has two horizontal asymptotes. Here, okay. And I want you to have these labeled, these points labeled. And this is actually at pi halves and negative pi halves. Okay, because, see, like right now, if you take a picture of this, see, like right now in my Calc 2 class, we're actually talking about the inverse tangent graph. And so it really helps the students if they've seen it before, if they kind of remember the basic look of it. Okay? And that's about it. So it goes from negative pi halves, and then it crosses at the origin, and then goes to pi halves. Okay? All right, any questions on that? All right, evaluation of the inverse trigonometric functions. If a problem says to find the exact value, try not to use a calculator. All right, so what are we going to use? Well, we're going to use the special triangles or the unit circle to find the values. So to find the exact values. All right. Oh, this was I have been teaching this for, I don't know, 20 years. And I could never get it straight as far as what quadrants, the different inverse trig functions. So there's not a blank here for this, but maybe underneath your last graph, you might want to draw this because it helps me. I don't know if it'll help you, but it helped me to remember. So inverse sine, I was looking for an angle in quadrant 1 and 4. Inverse cosine was an angle in quadrant 1 and 2. And then inverse tangent is also in 1 and 4. So the colors help me too. If you've got colored pencils, it's kind of, anyway, whatever. Okay? All right. So now, okay, so what we're going to do is we're going to be using so the 45, 45, 90 triangle and 30, 60, 90 triangle, we can put that information on the unit circle. And so a unit circle is a circle of radius 1. And so you draw these angles and you say, okay, at 0 degrees, see, the first number is the cosine, the second number is the sine. All right, so then what you do is you say, if I want the arc sine of radical 2 over 2, then you say, okay, the y value here is radical 2 over 2, that's the sine. So the angle is 45 degrees or pi fourths. Okay? Now, you can also use your special triangles. It's just that you've got to know if it's positive or negative, or in which quadrant. So let's just kind of practice with this a little bit. Okay. Oh, so here is the unit circle all worked out. Now you can you can download this. There's several different. There's a half a dozen versions on the internet. I've got a link to this on the Moodle page. So if you want to download it and put it in your notes, if you haven't already, we've worked with mainly the first quadrant here. Okay, but this has all of the angles for all 4 quadrants, and so that can be helpful. But just remember that you have your x and your y, which is the cosine and the sine. And then since the tangent is y over x, so like if I had the tangent, if I wanted the inverse tangent of 1 over radical 3, see, it would be pi 6 or 30 degrees, because the y over the x, see the 2's would cancel. So you'd have 1 over radical 3. Okay? All right. So let's look at the first one. So practice 2a. It says find the exact value. So the arc sine of -1. So what angle has a y value at the point at -1? So what's the angle where the point has a y value of -1? Is anybody?
270 degrees.
So 270 degrees. But usually for the angles that are in quadrant 4, for this we write it as a negative angle. So 270 degrees is correct. We could also write it as -90. So measuring down from the x-axis. Okay. So, but I would accept 270 degrees, but -90 is probably a better answer. What would it be? What would -90 be in radians?
Negative pi halves.
Negative pi halves. So when I say it's in quadrants 1 and 4, if the angle goes down, you want to write it as a negative angle. That's because usually that's how they want. When we said that the range was from negative pi halves to positive pi halves, that's kind of how they want it. Okay. Okay, so let's go to the next one. The arc sine of -2. So do you see an angle that has a y value of -2? Okay, Avery, you're shaking your head. So is that, what do you think? You see an angle that has a...
No, I don't.
You don't. And see, remember that the sine function, unless there's like an amplitude change or whatever, the normal sine and cosine live between 1 and -1. So the inverse trig functions have to have, their domain is between -1 and +1 for the sine. +1, -1 for the cosine. So that means something like number 2 there, the arc sine of -2, that doesn't exist. It's undefined. Okay? If you tried putting that in your calculator, you would get an error message. Okay? All right. So see if you can, I'll be quiet and you guys see if you can figure out the last two. All right, so Andres, what's the arc cosine of 1/2?
He went to the restroom.
All right, so do you volunteer as tribute?
No.
All
I
right.
kind of don't know what's going on.
Okay, so let me help you out here. So for arc cosine, you're looking at the x value. See, the x value is the cosine. So you want to find the angle that has a cosine of 1/2. So you look up here, you're looking for the x value of 1/2. Oh, there it is right there. Okay, do you see it? So what's the angle?
60 degrees.
60 degrees or pi-thirds radians. Either of those answers is correct.
What about 300 degrees or 5?
Okay, so what about 300 degrees? So right here. Well, do you remember at the top I said that, let's see, about the fourth blank, the range of arc cosine is between 0 and 180. So and then this little chart that I told you to write, this right here, this is telling you for arc cosine, you only look in those two quadrants. For arc sine, you only look in these two. For arc tangent, you look at these two. Okay? So arc cosine, you wouldn't look down here. This is telling you where to look.
I have a question. So, does
Just let me before answer the question. Let me just tell you the reason why it's telling you where to look is because it wants us to all get the same answer. See, math is not like English, where your interpretation of the author's passage is just as valid. No, we don't want interpretations. We want the answer. So because we want the answer, we're telling you we want everybody to look for the angle in quadrant 1 and 2 so that we can all get the same answer, 60 degrees or pi third. Okay, all right, go ahead. Sorry.
Oh, nothing, never mind.
I do have one question.
Okay, fire away.
So for that little circle thing you did with all the colors, is that for range or domain?
That is for the range.
The range, okay.
Okay.
Thanks.
All right. Okay, so the last one, the arc tangent of radical 3. Now, the arc tangents, of the three, the arc tangent is tougher than the sine and the cosine because those are right there. The tangent, you have to do the ratio. So it involves a little bit more. All right, so Kinsley, arc tangent of radical 3.
Wouldn't it be undefined? Or no?
Nope.
I am not sure then.
Okay, so here's what you're looking for. Is look for the angle where the ratio of the sine value, the y, over the cosine would simplify to radical 3. So let me give you an example. So this isn't your problem, but let's say I wanted the arc tangent of 1. Well, see here at 45 degrees, these two are the same. So when I do radical 2 over 2 divided by radical 2 over 2, anything divided by itself would be 1. So it's not obvious these tangent ones are because you have to reduce the fraction. But the arc tangent of 1 would be 45 degrees or pi fourths. So what would be the arc tangent of radical 3?
Is it 30 degrees?
It would be, okay, so 30 degrees, that would be 1 over radical 3. So you're getting closer because it's the y over the x. So 1 over radical 3 would be the tangent of 30 degrees. So what would give you radical 3 over 1?
60 degrees.
60 degrees. Good job. Because see, it would be, okay, so let's just write it out here. So it would be radical 3 over 2 divided by 1/2. Well, the 2's cancel, so that would give you radical 3 over 1, which would simplify to just radical 3. Okay? So the answer is 60 degrees or pi thirds. Now you might say, well, which is it? Well, it's whatever you want it to be. If you want the angle in radians or degrees, that's typically your choice. Or if I'm writing the quiz, it's my choice. All right? Well, let's keep going. Okay, a trig function applied to the inverse or vice versa only makes sense with the correct domain. Okay? Now, I know you probably don't understand what this is saying, but if if you have the correct domain in here, then what happens is a trig function and its inverse will cancel. Okay? So the sine of the inverse sine will cancel. The inverse sine of the sine will cancel. The only thing you have to worry about is if you don't have the right domain. You have to kind of switch it up a little bit. Okay? So let me, so the sine of the arc sine will cancel. Just leaving you with the number. Okay, so here's the tricky one. So Jill, you remember a minute ago where you had the answer 3 pi halves. But see, the problem is that the way that they write the domain of the inverse sine, they want it written as negative pi halves to pi halves. So if I have the arc sine of the sine of 3 pi halves, you can't just cancel and get 3 pi halves. What it is you say, well, the arc sine of 3 pi halves is negative 1. The sine of 3 pi halves is negative 1. And then the arc sine of that is negative pi halves. And so it doesn't work in that case to just cancel these and say, oh, that's the answer. Because 3 pi halves is not between negative 90 and 90. It's not between negative pi halves and pi halves. So what they want you to do there is rewrite it. So if you wrote 3 pi halves as negative pi halves, then you could cancel the trig function and the inverse trig function and get the answer that way. Otherwise, you have to do it a step at a time like this. Okay? Now, so let's see if you understand what I'm talking about here. Okay? Well, like here, okay, the arctangent is defined everywhere for all real numbers. So the tangent and the arctangent, you can just cancel that and get negative 5. Okay? So that's not a problem. Sine and arc sine are both, pi thirds is in quadrant 1. There's not a problem there. So you can just cancel and just get pi thirds. Okay? So what about these? Okay, so see if you can figure out if you can just cancel or if you have to rewrite the angle so that it's in the appropriate quadrant. All right, so Kinsley, on the first one, can we just cancel the sine and the arc sine here and get 3 pi fourths is my answer?
No.
That is correct. All right? So then what would be the correct answer, the final answer? And I've got a hint up there on the board.
Is it the square root of 2 over 2?
Well, that's the... Okay, that would be the... Okay, so the sine of 3 pi fourths would be square root of 2 over 2. And then what would be the inverse sine of square root of 2 over 2?
Or would it just be
Wouldn't it just flip so it's 2 over the square root of 2? The inverse? No.
No. The inverse is where you're looking for the angle, remember? You're thinking of cosecant, where you do the reciprocal. Okay? The inverse is not the reciprocal here. The inverse is the angle. So what angle has a sine of radical 2 over 2?
Is it pi halves?
Close. Look, do you have the unit circle in front of you?
The one that was just on the board?
Yeah. Do you,
No, I don't.
you have
Is
it?
it in
I
our
was just
book?
wondering if you have a copy of it. That's okay. So here's what I was looking for is, see, 45 degrees or pi fourths also has the arc has a sine of radical 2 over 2, and it's in quadrant 1. Okay? So here's how you can do it. You can either say, look, the sine of 3 pi fourths, well, 3 pi fourths is going to have the same y value as pi fourths, and now this is in the correct quadrant. Now you can cancel and just get pi fourths, or 45 degrees. Okay? The other way that you could do it is kind of the way that we were talking about it, is you could say, all right, the sine of 3 pi fourths is radical 2 over 2. And then to say, what angle has a sine of radical 2 over 2, that answer would be pi fourths, or 45 degrees. So you can either change the angle from the beginning if you need to cancel, or if that's confusing, then kind of the way that you were going about it was the right way. It's just that you've got to remember that those special triangles, the 30, 60, 90, and the 45, 45, 90 triangles, so that the arc sine of radical 2 over 2, you've got to know that that's pi fourths. Okay? So probably, I think it's easier as we get into more and more of this, is to deal with the unit circle that I had up on the board earlier. So I would maybe I would recommend, if you're struggling with this at all, is print that out and have it in your notes so that you can refer to it. Because I think let's go back and use the unit circle and see if maybe it's easier to follow along here. Okay, so the arc sine. Okay. So here, if I say this, so the sine of 3 pi fourths. So then you say, okay, that's right here, radical 2 over 2. But then when you do the arc sine, you've got to be in one of these two quadrants. So then you say, what angle has a y value of radical 2 over 2? Well, that matches right here in quadrant 1. So the answer is pi fourths, or 45 degrees. Okay? So when I ask a question with the arc function, you got to make sure you're in the right quadrant. Okay? So that's what this kind of whole thing is trying to teach you. All right? Let's try the next one. All right. So Kinsley, I'm really not picking on you. I'm really not. I mean, it's just the way, the luck of the spin, right?
I believe it's 0 because the cosine and the arc cosine cancel, correct?
Yes. Yes, because see there, you're in the right quadrant. You're actually between 1 and 2. Right? So they will just cancel at that point. It's much easier, so that's it. Okay? All right. Any questions on that? All right.
Excuse me, sorry, we have a question.
Yeah.
I don't even know what I don't know on this. I'm very lost.
Specifically on practice 2BI. 2B1.
On this one?
Yes.
Okay. So, do you know the sign of 3 pi fourths? If I just asked this part right here, do you know that?
The 270, but this is talking about the y and x values, I think.
So, okay, 3 pi fourths isn't 270. That you're thinking 3 pi halves. 3 pi fourths is in quadrant 2.
5. Oh, darn it. Okay, so the sine of 3 pi fourths, that's like the y and x value thing, right?
Yep.
So sine
the
is
sine
the y
is the
value,
y.
right?
The sign is the y.
Okay. And so, just didn't have this to look at. Hold on.
So, okay, so let's back up. Okay, wait. Let's back up. Okay, so if you've got the unit circle in front of you, that's one thing. But if the question was, find the sine of 3 pi fourths, okay? Well, see, you've got to know that that's in quadrant 2. The reference angle is pi fourths, so it's the same thing as the sine of pi fourths. Remember when we did reference angles and doing trig functions outside of the 30, 60, 90 triangle? Okay? So
Okay.
I would suggest that you haven't done enough practice on those problems. And so that's why you're a little bit lost, is because, see, I'm assuming all the stuff last week, you're masters of that right now. Okay? Right? So if you haven't practiced on those earlier sections, that's what you need to do, because everything's building on what we did before. So those lessons on finding the reference angles so you can find the right trig value, that's where you need to work. Okay?
Thanks.
Thank you.
Sure. Okay. All right, let's... Okay, so what about this one? Is pi, is that in the right quadrants? Will this just cancel, leaving us with just pi? Yes or no? Yes or no? Thumbs up, thumbs down. The answer is yes, it will. Because the inverse cosine has to be between 0 and 180. Okay? So you wrote that down earlier. And so if it is, then these will just cancel, leaving us with just pi. See, if it's when they're not in the right quadrant, that's when you have to do some work. Okay? All right, now, so I told you can download the unit circle. But let me just tell you a quick way that you can actually just write it yourself, okay? At least in quadrant 1, is you start with the angles. And all the angles are from your special triangles, okay? You have 0 to 90, and then your other angles are from the 30, 60, 90, 45, 45, 90 triangle. So you have 30, 45, and 60, okay? So 0, 30, 45, 60, 90. Okay? And then in radians, that's 0, pi 6, pi 4ths, pi 3rds, pi halves. Okay? Now, to get the numbers, the x and the y, the cosine and the sine, the way to memorize these is that if you just memorize this pattern, it goes radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. And then you simplify. Radical 0 over 2 simplifies to 0. Radical 1 over 2 simplifies to 1/2. These don't simplify. Radical 4 over 2 simplifies to 1. And then you start with the cosine. So this is radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. And then the pattern repeats itself going back. Radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. So, I mean, when I was a trig student, I had to memorize it, the whole thing. I don't care if you print it out and have it available, but you need to know it. You need to know how to use it, okay? So if either work on trying to practice, the more familiar you are, the more that, you know, if I just say, what's the cosine of 30, and you can come up with radical 3 over 2, that will help you, okay? But this is like putting those two special triangles, the 45, 45, 90 triangle, the 30, 60, 90 triangle, the sine and cosine all in one place. It's like putting it together. So have that either in your notes or print it out as you're working on problems, okay? Because if as we go on, if you don't have it, it's going to be tough for you, okay? So any questions on that? Okay, now sometimes if you get stuck, when finding algebraic expressions for inverse trig functions, it's useful to draw a triangle. This is also helpful if it's one of the angles that's not on your unit circle. Okay, so let me show you how a triangle can help. Okay. All right. So let's say we want the tangent of the inverse sine of negative 4/5. Okay, now, see, these are not going to cancel because it's not like the sine of the inverse sine. So they're not going to cancel. So what you want to do is draw a triangle. So start with in the inside, and you're going to want a triangle where an angle of your triangle has a sine of negative 4/5. Okay? So, and then once you draw that triangle, draw that angle, then you're going to find the tangent of that angle. All right, so first, let's draw the triangle. All right, so here we draw a triangle with a sine of negative 4/5. So so that would be the opposite over the hypotenuse. So we have this triangle coming down. Why don't we have it going up? Well, because then it would be a positive 4 going up. So if we need a negative for the length of our opposite side, just draw your triangle going down. Okay? So we're measuring this angle. So this sine opposite over hypotenuse. Now, to get the third side, we're going to use the Pythagorean theorem, and we get 3 for the third side. Then once we have 3 for the third side, then we can say, okay, now the tangent of this angle is opposite over adjacent, so negative 4/3 would be our final answer. So once we have the triangle, it's not so bad. So what I would like you to do is do that next problem, practice 2C, before class tomorrow. So find the cosine of the arctangent and do it like this, where you try to draw a triangle first, solve the triangle, then answer the problem. So we'll go over it first thing tomorrow. Okay?